Hello. Welcome to today's lesson on calculating current. Today, the focus of our lesson will be on understanding how to calculate current. So far, you are familiar with the general concept of current, understanding it as the flow of electric charge in a circuit. Building on this understanding, we can now delve into the precise relationship between current, charge, and time. This concept will deepen our knowledge of electric circuits and enhance our grasp of how electrical energy is managed and utilized in various applications. The rate of flow of charge determines the current. If we have two circuits, and in the first circuit 50 charges, or electrons, pass a point every second, whereas in the second circuit only 5 charges pass per second, the first circuit has a higher current. More charges passing a point means a higher current. Similarly, if the first circuit has 5 charges passing every second, and the second circuit has 5 charges passing every 10 seconds, the first circuit again has a higher current. This shows that a higher number of charges per second, or a faster movement of charges, results in a higher current. The relationship between current, charge, and time is given by the formula charge flow equals current times time. If we want to rearrange this, we could write it as current is equal to charge divided by time. Here, charge Q represents the total number of electrons passing through a point, measured in coulombs. Time T represents the duration over which this charge flows, measured in seconds. Electric current is then measured in amperes, where 1 ampere equals 1 coulomb of charge flowing per second. By using this formula, one can determine the current in any circuit. For example, if 10 coulombs of charge pass through a point in 2 seconds, the current is 10 coulombs divided by 2 seconds, which equals 5 amperes. Let's apply what we've learned to a few specific problems to consolidate our new knowledge about electricity and current. Here is our first question on calculating current flow. Suppose we have a situation where a total charge of 15 coulombs passes through a point in a circuit over a period of 3 seconds. Calculate the current in the circuit. First, use the relationship between charge, current, and time. Recall that current is defined as the rate of flow of charge over time. The formula to use here is I equals Q over T. Then, substitute the known values into the formula. Here, Q equals 15 coulombs and T equals 3 seconds. So, the current is equal to 15 over 3, which equals 5 amperes. So, the current flowing through the circuit is 5 amperes. Now we will look at a question on determining the charge flow given the current and time. Imagine you have a circuit where a current of 3 amperes flows for 4 seconds. First, we must identify the formula that links charge flow with current and time. This is Q is equal to I times T. Now we can substitute the known values into the formula. Here I equals 3 amperes and T equals 4 seconds. So Q equals 3 times 4. Finally, we calculate the total charge, which is 12 coulombs. So, a total charge of 12 coulombs passes through the circuit over the 4 seconds. By working through these examples, you will understand how to calculate current and charge through given parameters. In today's lesson, we delve deeper into the concept of electric current and how it relates to the flow of charge in a circuit. We learned that current is determined by the rate at which charge flows through a point in the circuit, described by the formula current equals charge divided by time. Through practical examples, we calculated current and charge in various scenarios, reinforcing how these quantities are interconnected. This understanding of current as the flow of electrons lays the groundwork for deeper insights into electrical circuits and their behavior.